Happy day, everybody. This is mathematics physics fundamentals on YouTube. My name is Orekoya Olusegun, physics mathematics fundamentals on YouTube. Today, we want to go into the continuation of this topic, factor theorems and the remainder theorem. Before we go into today's topic, please do not forget to like, share, subscribe, and click on the notification button to have more of my videos. Now, look at this question here. The question says find the remainder when x plus 4 divides x cubed plus 2x squared minus 3x plus 5. The second question says factorize x cubed plus 5x squared minus 4x minus 20. Then the third question says given that x plus 1 and x minus 2 are factors of x cubed plus px squared plus qx minus 6. Question A says find p and q. Question B says factorize this particular expression after finding p and q completely. Now, this is how we are going to solve this problem. Look at this question number 1. Question number 1 says we should find the remainder. Now, question number 1, we are given factor. We are given this factor, and the factor we are given is x plus 4, and then the polynomial f of x that we are given is x cubed plus 2x squared minus 3x plus 5. So we are asked to find the remainder. We are asked to find the remainder. Find the remainder. This is the procedure. There are two methods. Method A, we can use what is called remainder theorem. Remainder theorem. Remainder theorem. So the theorem is this. When you are doing the remainder theorem, this one is not a factor, it's a divisor. It becomes a factor when the remainder is 0. So this one is actually a divisor. I have explained the meaning of divisor, dividend, and remainder the other time. What I mean by that is, let me say I have 7 divided by 2. You know that 2 in 7 is 3, then remainder 1. So this particular one you have here is called divisor. This one that you have here is called dividend. And then that 3 that you have there is called the quotient. So then this one is called the remainder. So you must take note of the names and the relationship. Now, we want to find, using the remainder theorem, you set this divisor to 0. You say x plus 4, let x plus 4 is equal to 0. So therefore, you carry plus 4 to the other side. This becomes minus 4. Now, according to the remainder theorem, you replace x with minus 4 in this particular polynomial given. So what we are going to do now, just say remainder. Remainder will now be, you substitute minus 4 raised to power 3 plus 2 bracket minus 4 square minus 3 bracket minus 4, then plus 5. And then I want to remind us of something. Anytime your power is odd, whatever you are going to have here will be negative. So this will just be minus. Then 4 raised to power 3, that is 4 times 4 times 4, that's 64. Here, the power here is even. So whatever you are going to have here will be positive. So it's going to be plus 4 raised to power 2 is 4 times 4, that's 16. 16 times 2 gives us 32. Then minus times minus, we have plus. 3 times 4, that gives us 12. Then plus 5. And then we can add this one together, first and foremost. 32 plus 12 plus 5. 2 plus 2, that's 4. 4 plus 5, that will give us 9. 3 plus 1, that will give us 49. Sorry, this is 12. 2 plus 2, 4. 4 plus 5, 9. Then we have 3 plus 1, that's 49. So then we have minus 64. So 64 take away 49. we borrow here, this is 14. 14 minus 9, that's a 5. Then 5 take away, that's a 1. So that means our remainder that we are going to have as our final answer is 15. So the remainder for this problem is 15. So the second method is a long division method, which we are going to see in solving this one of these problems that we have on the board. Now let's move down to solving the second problem. The second problem says that we should factorize this particular polynomial. Factorize x cubed plus 5x squared minus 4x minus 20. To factorize this particular polynomial, we normally look at the highest power of the single variable x. The highest power is 3. That means this remainder will have 3 sets of factors. So the factors of this polynomial, we have this shape of x plus or minus a, x plus or minus b, then times x plus or minus c. If you open this factor, when you open this bracket by multiplying this factor, we are going to have a polynomial that will have this type of a format. And the highest power of x will be x cubed, because x times x squared, x squared times x, that will be x cubed. So that's the format of the factors that this kind of polynomial we have. So anytime you are given a problem like that, look at the highest power of the variable, and you write out this according to if the highest power is 2, that means you are going to have 2 factors. Now the next thing is you look at this product ABC. This product ABC must be equal to this constant term that is here. Let's say must be equal to 20. So the product ABC is like obtaining factors of 20. Now you know that 20 can have different factors, like 20 times 1 can have 10 times 2. It can have 4 times 5. Then it can equally have that's all. So one of these factors, when we substitute for ABC, we definitely bring out the factor of this polynomial. Now I want to start with the factor 1 using this particular first factor here. So that means picking this factor 1, that means a will be 1. That's I'm going to test x plus or minus 1. So let me test x plus or minus 1. I'm picking this factor. Let me take factor x plus 1. According to factor theorem, we set this equal to 0. So we are going to test carry plus 1 to that side. We are going to test when x is minus 1 in this polynomial. If after I substitute this minus 1 here, my result as a remainder give me 0, that means x plus 1 will be a factor. Let's try. Putting here, we have minus 1 raised to power 3 plus 5 times minus 1 raised to power 2 minus 4 bracket minus 1, then minus 20. So minus 1 raised to power 3 will give me minus 1. Minus 1 raised to power 2 give me 1. 1 times 5 give me plus 5. Minus times minus give me plus. So then 4 times 1 give me 4. Then I have a minus 20. If you look at the whole of the thing that is here, it can never be equal to 0. So that means x plus 1 is not a factor of this polynomial. Now let me try x minus 1. X minus 1. Set x minus 1 to 0 like the way I've done before. So that means I'm going to you carry minus 1 to that side. That means I'm going to test when x is 1. So I will put 1 here. So I'm going to have 1 raised to power 3 plus 5 times 1 square minus 4 times 1 minus 20. So 1 raised to power 3, 1 plus 5 minus 4 minus 20. If you look at this, it will not give me what I'm looking for. So that means s plus or minus 1, they are not factor of this polynomial. So we move down to the next number, which is 2. So you can put that 2 here again. You put it there. So the one of the factor will take the shape of x plus or minus 2. Now let me pick s plus 2. Let me set it to 0. I'm picking this factor out of this. So carry plus 2 here. We have s is equal to minus 2. So we test minus 2 in the given polynomial there. So we have minus 2 raised to power 3 plus 5 times minus 2 raised to power 2 minus 4 brackets minus 2 minus 20. So minus 2 raised to power 3 will give me minus 8. I've said the other time that anytime you are having odd power, whatever you are going to have here will be negative. Since I'm having even power, my result for the sign here will be positive. So 2 raised to power 2 for 4 times 5, that's 20. Minus times minus, that's plus 4 times 2, give me 8. Then minus 20. You can see that plus 20 minus 20 is 0. Minus 8 plus 8 will give me 0, remainder 0. So that means this particular s plus 2 is a factor of this polynomial. I can continue to be testing for the second one. After I've tested 2, I can go to 4. Then from 4, I can try 5 if 4 doesn't work, like that. But to be able to shorten the work, I will use the factor that I have generated using the factor theorem to divide this polynomial using the long division method. So by long division method, this is how we go about it. You recall, we have established that s plus 2 is a factor out of the 3 factors that we have predicted. So by long division method, like in my last video, I indicated that the line of work will be in such a way that we have the divisor function will be outside here, then the quotient function will be here, then the dividend, the dividend, that's your polynomial, f of x will be here, that the remainder will be here. Take note of this. This place will be the quotient, this place will be the divisor, the location of the divisor. This place will be the location of what is called the dividend. Take note of that. And whatever you have down under this dividend at the end is the remainder. Please take note of that. That's how we are going to spread the line of our work. Now, so we are going to use this factor to divide this now. We put the divisor outside, which is s plus 2. Then we write our polynomial inside. Then plus 5s squared minus 4x minus 20. So what you are going to do is to use this to divide the first term here. That means s cubed, this s cubed divided by this x, it will cause remain s squared. So you write the s squared up. Now use the two of them to multiply. X times s, it will remain, we use the s plus 2, that okay, s squared. So you put it as s squared there. The x times s squared will give us the s cubed. Then plus these two, use it to multiply this again. That's 2s squared. After you have done that, do subtraction. This subtraction, this sign of subtraction, we affect this way. This will become negative. This one cancel out. S cubed minus s cubed will give you 0. So we now have plus 5s squared. Take away 2s squared. That will give us 3s squared. After you have done the subtraction, move down the next factor down, which is minus 4x. Start the process again. Use this to divide this. That is 3s squared. Use the x to divide this. That will give me ordinary 3x. So you write plus 3x here. Now use these 2 to multiply this 3x. So x times 3x will give me 3s squared. Plus 2 times 3x will give me plus 6x. After you have done that, do subtraction again. So this subtraction means this becomes 0. Then this minus affect this. This becomes minus 6x. Minus 6x minus 4x give me minus 10x. After you have done your subtraction, bring out the next term down. That will give us minus 20. Now, use this to divide this minus 10x. So minus 10x divided by this x will give me minus 10 because this cancel this. So I have minus 10 there. Use these two to multiply this minus 10. X times minus 10 will give me minus 10x. Then plus 2 times minus 10 will give me minus 20. Then do subtraction. This becomes 0, 0. So that means this is a factor, and this quadratic function too is also a factor. Now, you know quadratic function, the highest power of x is 2. That means this function that you have here is going to have 2 factors. So what we are going to do to get the remaining 2 factors is to factorize this quadratic function. So let me bring this quadratic function out down here. X squared plus 3x minus 10. So this is how we factorize quadratic function. We know that the highest number of factors is going to have is going to be 2, because the highest power of variable x is 2. So I'm going to have something like x plus a bracket x plus b. That's the nature of this particular quadratic equation. So think about two numbers that you multiply together to give you minus 10. You add them together to give you plus 3. I think I have plus 5 times minus 2. Plus times minus 5 times 2 give us 10. Then plus 5 minus 2 give me plus 3. So I will replace this plus 3 with this 5 and minus 2. So instead of having plus 3x, what I'm going to have now is going to be plus 5x, then minus 2x, minus 10. So what is common here is x. You factorize x out. We have x plus 5. Whatever you have written here, quickly write it there. Think of a number you used to multiply to give you this. That's minus 1. So we are having this factor. This x plus 5 is common. So we are going to have x minus 1 times x plus 5. So this is the factors of this quadratic function. So that means this particular polynomial function that we want to factorize, let's call it f of x. So my f of x now, which is this polynomial, the factor in a factorized form is going to be this factor together with these two other factors. So I'm having x minus 1 times x plus 5, then times x plus 2. You can rearrange the way you have written this multiplication. It obeys the associative property in mathematics. It's either you write this one first, follow